What does it take to turn raw gold into perfectly finished 3.75-gram investment bars? The process begins here, where every tiny amount of this The solid billets now enter a rolling mill, where powerful steel rollers gradually compress them into thinner and longer strips. Instead of reducing the thickness in a single pass, workers repeatedly feed the gold why accurate weighing remains one of the most carefully controlled stages of the entire process. What does it take to turn a large piece of leather into a precisely finished belt? In this workshop, most of the process still depends on skilled hands working alongside specialized machines. The process begins with workers measuring the leather and marking long cutting lines across its surface. Each section is then carefully cut from the hide. Good layout matters because leather is a natural material, so thickness and surface quality can vary from one area to another. The cut leather is passed through a splitting machine that reduces it to a more uniform thickness. Rotating blades remove excess material, while the worker controls how the leather enters the machine. Consistent thickness is important because the belt will later be built from several layers. If one section is too thick or too thin, the finished belt can feel uneven and become difficult to stitch cleanly. The prepared leather is now cut into long belt-shaped strips and smaller reinforcement pieces. Workers use templates, cutting tools, and presses to keep each component consistent in width and shape. Some ends are also thinned or skeeved. Removing material from these areas allows overlapping layers to join without creating bulky sections in the finished belt. Several leather strips are now brought together to build the main belt body. Workers apply adhesive evenly along the surfaces before carefully aligning the layers by hand. The pieces are then pressed and rolled together so the bond remains flat along the entire length. This layered construction improves stiffness and helps the belt hold its shape, while manual alignment prevents the edges from shifting before the adhesive sets. Material is trimmed away, and specialized rollers compress the belt to create a cleaner, more consistent profile. This step may look simple, but the worker must constantly guide the long strip. The machine supplies steady pressure, while human control keeps the belt straight and prevents damage to the leather surface. The edges now receive a series of finishing treatments. Workers smooth the leather, apply finishing compounds, and repeatedly rub or press the edges until they become more uniform. Some tools also use heat and pressure to compact the surface. This reduces loose fibers and gives the belt a cleaner edge that is more resistant to wear. Much of this work depends on touch and experience rather than full automation. The belt body now moves to the sewing machines. Workers guide each long strip under the needle while the machine produces a continuous line of closely spaced stitches along the edge. The stitching does more than add decoration. It mechanically locks the layers together, reinforcing the adhesive bond and helping the belt maintain its structure after years of bending and pulling. To the hardware. Metal buckles are fitted to one end, while another machine punches a row of precisely spaced adjustment holes into the opposite end. The machines create repeatable positions, but workers still align every belt individually. Even a small positioning error would make the buckle or holes look noticeably uneven on the finished product. The workshop. A forged aluminum alloy wheel begins as a solid cylindrical billet, long before its spokes and polished surfaces appear. Workers first move large aluminum bars to an industrial saw, where they are cut into thick sections of controlled weight and size. Accurate cutting matters because each billet must contain enough material to form the entire wheel without unnecessary waste. The prepared blanks are then transferred toward the heating line. The aluminum billets are heated until the metal becomes much easier to deform under pressure. Rather than melting the aluminum, the factory keeps it solid and raises its temperature enough for forging. This helps the material flow inside the dies while maintaining a dense internal structure. Automated equipment controls much of the heating and transfer, reducing temperature variation between one wheel blank and the next. The hot billet now enters a series of enormous forging presses. Each press applies tremendous force, gradually transforming the simple cylinder into the basic shape of a wheel. Multiple forming stages are used instead of trying to create the entire geometry in one operation. Forging also compresses the aluminum structure, helping produce a strong component capable of handling repeated road loads, impacts, and vehicle weight. Robotic arms transfer the hot wheel blanks between additional presses, where the rim and spoke areas continue taking shape. Using robots here improves both speed and safety because the parts are still extremely hot and heavy. The machines provide enormous forming force, while carefully designed dies determine the geometry. By the end of this stage, the blank already resembles a wheel, although its surfaces are still rough and oversized. The forged wheels are now heat-treated before precision machining begins. Controlled heating and cooling help the aluminum achieve the mechanical properties required for automotive use. Afterward, workers inspect the blanks and load them into CNC machining centers. From this point forward, the process shifts from heavy forming to extremely accurate material removal. CNC machines now cut the wheel to its final dimensions. Rotating tools machine the spokes, bolt holes, center bore, rim surfaces, and other critical features, while coolant removes heat and metal chips. The forged blank provides strength, but CNC machining provides precision. Workers also inspect and deburr the wheel by hand, removing sharp edges and checking areas that automated cutting tools may not finish perfectly. The freshly machined wheels move onto an automated surface treatment line. Robotic handling systems transfer each wheel through cleaning and preparation stations, removing machining residue and preparing the aluminum for coating. A clean surface is essential because oil, dust, or metal particles can prevent the finish from bonding properly. Machines provide consistent treatment, while workers continue checking surface quality between stages. Robotic spray systems now apply the black protective finish, while the wheels rotate for more even coverage. The coated wheels then enter a heated curing oven, where controlled temperature helps the finish harden and bond to the aluminum. This coating is not only about appearance. It also creates a protective barrier against moisture, road dirt, and everyday environmental exposure. After curing, workers inspect each finished wheel under bright lighting, checking the coating, surface finish, and overall appearance. The wheels are then protected with packaging materials, stacked securely, and moved by automated handling equipment toward the shipping area. From a simple aluminum billet to a finished automotive wheel, the process combines massive forging presses, precision CNC machines, robotic coating systems, and skilled human inspection at every critical stage. From precious gold bars and handcrafted leather belts to forged aluminum wheels, every product tells the same story. Precision comes from the balance between skilled workers and powerful machines. Each stage transforms raw material into something valuable, durable, and carefully engineered. If you enjoyed these satisfying manufacturing processes, like the video, subscribe to KenTT Machine, and tell us which factory process impressed you the most.